Today we're going to talk about 5 SAT math problems you must know how to do, and all of these problems have been taken from official digital SAT math practice test sections. So in this first problem, we are given an equation x squared minus 34x plus c is equal to 0, and we're told that c is a constant and the equation has no real solutions if c is greater than n, and we're asked what is the least possible value of n. So remember, this equation here is in the form of ax squared plus bx plus c is equal to 0. So our a here, remember, if we see an x squared, that means that there's a little 1 in front of the x squared, so our a is equal to 1. Our b here is going to be equal to negative 34, and our c here is just going to be c. So we know that if b squared minus 4ac is less than 0, then we have no real solutions. And this is a rule called the discriminant. So our b here is negative 34, so if we take negative 34 and square it, and then minus 4 times a, now our a here is 1, and then times our c, and our c here is just c, we know that this has to be less than 0. So negative 34 squared is 1,156, and then minus 4 times 1 times c, that's just minus 4c, and we know that this is less than 0. So we add 4c to both sides, we get 1,156. That is less than 4c by adding 4c to both sides. And then we divide both sides by 4, and we're going to get 289 is less than c, or if we just flip this around, c is greater than 289. So our answer here, our least possible value of n, if c has to be greater than 289, then our least possible value of n is going to be 289. So this problem here is definitely one of the toughest SAT problems I've seen. So we're told that the graph of x squared plus x plus y squared plus y is equal to 199 over 2, and that this graph is a circle. And we're asked what is the length of the circle's radius. So firstly here, we need to remember what the equation of a circle looks like. So remember, it is going to be x minus h squared plus y minus k squared, and that's equal to the radius squared. Now also remember here, just h and k as an ordered pair is our center of our circle. So to do this, we're obviously going to have to make this equation here into this form. Now to do this, we're going to have to factor and create perfect squares out of everything, because we can see here x minus h squared and y minus k squared are both perfect squares. So to do that, starting off here, we know to put it in this form, we start with an x, and then we have something here, some kind of constant, x plus or minus some kind of constant. Now, in this case, actually, it's just going to be half of the constant in front of that x there. Now, in this case, the constant in front of that x is just going to be 1, right? Because 1x is equal to x. So it's going to be half of 1, which is 1/2. So we'll have x plus 1/2 squared. Now remember, x plus 1/2 squared is equal to x plus 1/2 times x plus 1/2, right? It's not x squared plus 1/2 squared. So that's going to be equal to x squared plus 1/2 x plus 1/2 x plus 1/2 times 1/2, which is 1/4, right? And this is equal to x squared plus x, right? Like we originally had, and then plus 1/4. Now it's going to be the same thing with the y's here. So let me write out this new equation here. We now have x squared plus x plus 1/4, and just doing the same thing with the y's, exactly the same process, right? And luckily in this equation we have the same numbers. They could be different between x and y, but in this case they are the same. So then we'll have plus y squared plus y plus 1/4. And then remember, this is all coming from x plus 1/2 squared, and then plus y plus 1/2 squared. Now this is equal to, right now, 199 over 2, right? Currently we have 199 over 2 in that r squared spot. But we kind of just pulled 1/4 and 1/4 out of nowhere, right? And 1/4 plus 1/4 is equal to 1/2. So if we added 1/2 to the left side, which we did here, right? Because of those two 1/4s, we have to add 1/2 to the right side. So 199 over 2 plus 1 over 2, it's just going to be 200 over 2 or 100. So rewriting this new equation, right, we have x squared plus x plus 1/4 plus y squared plus y plus 1/4. And we know that this is equal to 100. So just reorganizing this, just refactoring it like we had right here, we know that we're going to have x plus 1/2 squared plus y plus 1/2 squared, and that's equal to 100, right? And obviously from the original equation here, we know that 100 is equal to our radius squared, so our radius must be equal to 10, and that's our final answer. So in this problem here, we are given a right triangle with a hypotenuse and one of its angles. Now, we know this is going to be a 30, 60, 90 triangle, right? Because we're given two angles, 30 degrees and the 90-degree angle. And so that means we know that all of them have to add up to 180 degrees because it's a triangle, so the third angle must be 60 degrees. So in a 30, 60, 90 triangle, we have some rules we can follow. So this is the 90-degree angle, and we have the 30-degree angle here, and the 60-degree angle here. So the side between the 90-degree angle and the 30-degree angle is going to be x root 3. The side between the 90-degree angle and the 60-degree angle is going to be x, and then the hypotenuse is going to be 2x. So the hypotenuse we're given here is 54, so we know that 2x is equal to 54, so x has to equal 27. So if x equals 27, that means this left side here is 27, and then the bottom side is just x root 3, or x times root 3, so it's just going to be 27 times root 3. So we're looking for the tangent of A. Now, this is going to come from our SOHCAHTOA rule, and if you don't know too much about SOHCAHTOA, feel free to check out my SOHCAHTOA video. But we know that the tangent of any side, or any angle, sorry, is going to be the opposite side divided by the adjacent side. Now, the opposite to A is going to be 27 root 3. And then the adjacent to A is going to be 27. So then these 27s are going to cancel out, and we know that the tangent of A will then be equal just to root 3. So that's our final answer. For the next problem here, we have a rectangle that's inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. So I've drawn that there on the right. And then the diagonal of the rectangle is twice the length of the shortest side of the rectangle, and the area of the rectangle is 1089 times the square root of 3 square units. And we're asked what's the length of the diameter of the circle. So first of all, the diameter of the circle is going to be the same as the diagonal of the rectangle. So let's draw out that diagonal here. So we have the diagonal, and we're told that the diagonal is twice the length of the shortest side of the rectangle. So if I call the shortest side of the rectangle x, the diagonal is going to be 2x. Now you might recognize from our previous problem that the missing side here is actually going to be x root 3 because this is actually going to be a 30, 60, 90 triangle. Now I'll actually show you how to derive that here. So using Pythagoras theorem, I'm going to call this side b. So we know that b squared plus x squared is equal to 2x squared. So therefore b squared plus x squared is equal to 4x squared. Let's subtract x squared from both sides. We get b squared is equal to 3x squared. Square root both sides, we get b is equal to x times the square root of 3. So that's how we can derive that this missing side here is x times the square root of 3. Now we're told that the area of the rectangle is 1089 times the square root of 3 units. Now remember, the area of a rectangle is equal just to the length times width. So let's do that. Let's do x times the square root of 3 times x, and that's equal to x squared times the square root of 3. And we know that's equal to our area here, which is 1089 root 3. So let's divide root 3 from both sides, so that cancels out, and we get x squared is equal to 1089. And then if we just find the square root of both sides, we get x equals 33. And then the diagonal here, which is the same as the diameter of the circle, is equal to 2x. So that's 2 times 33, and that's equal to 66. So 66 square units is our, or sorry, it's just 66 units is our diameter. This last problem here is all about our exponent rules. So just a quick refresher, remember that let's say we have the square root of x. Remember that is equal to x to the 1/2. And this continues with, let's say we take the cubed root of x. That is equal to x to the 1/3. So then looking at this problem, we have 4 to the 8c is equal to the cubed root of 4 to the 7. So let's just simplify this cubed root of 4 to the 7 a little bit. So this is the same as 4 to the 7 to the 1/3. So this is equal to 4 to the 7/3. So then we're told that 4 to the 8c is equal to this. So 4 to the 8c is equal to 4 to the 7/3. So therefore, 8c must be equal to 7/3. So let's multiply both sides by 3, and we're going to get 24c is equal to 7, and then divide both sides by 7, and we'll just get c is equal to 24 divided by 7. So 24 divided by 7 is our final answer. So thank you so much for watching, everyone, and my email and link for one-on-one tutoring is in the video description, and let me know in the comments or by emailing me if you have any questions.